Okay. Hello everyone, my name is Tsing. Today I'm going to introduce the paper published on ACS Materials, which talks about the covalent organic frameworks with fluorescein sensing properties for uranium ion. First, we'll review the phenomena of fluorescein. As a molecule absorbs energy, it is promoted from the ground state to the excited state. It is then vibrational relaxation to the lowest vibrational state of S1 and returns to S0 while emitting energy in the form of fluorescent signal. Fluorescent mechanisms have been identified in donor and acceptor, furthermore in COP sensors. In photo-induced electron transfer, the electron donor and acceptor form a charge transfer complex, which relaxes from the excited state to the ground state with emission of the photon. And a fluorescent signal is observed, and the extra electron on the acceptor is returned to the donor in the last step of the process. When an analyte is added to a fluorescent-based sensor, which typically manifests in one of the changes in the fluorescent spectrum, it is called fluorescent quenching. The fluorescent quenching can occur as a result of dynamic quenching or due to static quenching. This paper is based on static quenching. In static quenching, a complex is formed before excitation occurs. The complex has its own unique properties, such as being non-fluorescent and have a unique absorption spectrum. COPs are a kind of novel organic materials consisting of light elements through covalent bonds. However, the reported COPs usually exist in the form of insoluble polycrystalline powders. Notably, reducing the size of COP is an effective approach to enhance their solubility. In this research, they start from bulky materials and break them into smaller nanostructures by ultrasonic treatment, taking advantage of the stability difference between non-covalent and covalent bonds in 2D COPs. Based on imine can be produced by the reaction of aldehyde and amine. DABA can serve as an amine monomer due to the hydrogen bonding between the carboxyl groups. Therefore, they select DABA to prepare framework materials. Subsequently, they destroy the hydrogen bonding using ultrasonic method and get 55% yield. COQD1 exhibits a strong fluorescent property and was employed for uranium ion. Significantly, a clear fluorescent color changes could be observed under UV light. The HCOF and COQD were thoroughly characterized using various techniques. For example, the left side is the FTIR. Compared with reactants, we can observe that the characteristic peaks disappear in the HCOF spectrum, confirming the successful consumption of the reactant. The middle one is the comparison of FTIR between HCOF1 and COQD1. The presence of broad peak around 3,300 wave number in COQD1 was attributed to the exposure of the carboxyl group. In addition, the peaks of the hydrogen bonding disappeared. The left one is HRTDN image. As shown in figures, COQD1 was uniformly distributed in aqueous solution with an average size of about 3.9 nanometers, indicating that the COQD have the quantum dot morphology and good dispersity. The right one is the XPS spectrum after quenching by uranium ion. The changes of binding energy show that the oxygen and nitrogen atoms are coordinated with uranium ion. In conclusion, the author presents a fancy approach for the preparation of novel COQD and find the fluorescent quenching to the uranium ion. providing a potential tool for environmental monitoring and nuclear waste management. Alright, thank you for watching the video.